Okay, here we have what's called Cramer's rule. It gives us yet another way to solve systems of equations like this. When you have a invertible n by n as your matrix A. Okay, so the textbook gives a proof of this, follows from the theorem that gave us the formula for the inverse. This guy. So Cramer's rule can be proven from this formula. So it's natural that it comes after that formula in the notes. So what it says is that you can find your x1, x2, x3 just by taking ratios of certain determinants. Now it's a very special thing. You're taking the matrix A and you're replacing a column with this vector B. Okay, this is a little bit of word salad, so let's do an example to illuminate. So here's my system of equations, and I'm going to find just x2. Now, Cramer's rule says that Gabriel Cramer, his name was, that is the footnote number 5 that you may have noticed on the theorem. Refers to Gabriel Cramer and a bit of his bio. Anyways, Cramer says that x2 will be the determinant of a2 divided by the determinant of a. So from here, we can extract A is the coefficient matrix, so 5, 7, 2, 4, and A2, the 2 says I should take the second column, this one, and replace it with my B. So the second column should be replaced with 3, 1, and the first column stays the same, or the rest of the matrix stays the same. Okay, from here we get determinant of A is 20 minus 14, holy moly, guacamole. My God, 6. And here we get determinant of A2 is 5 minus 6 is negative 1. So my Cramer gives me negative 1 over 6, and I'll sneak a peek at my answer. Aha, good job, Jordan. You're really pulling your weight here. Okay, so relatively simple formula. You know, if you want to find xn, then you take the determinant of an divided by determinant of a. Seems very simple, but in practice, this is computationally a little bit arduous. Anyways, give it a shot in this exercise down here. And the answer is, where's the answer? Oh, minus 3/4. Minus 3/4 is what you're shooting for. Okay, what do we get? I get A is, let's skip straight to the determinant of A is determinant of the coefficient matrix, 9, 1, negative 1, 1, negative 1, 5. And how would I sort that out? Well, with my determinants, what I like to do is only do replacement operations. So I'm going to go row 2, doesn't really matter, but just create some zeros quickly. Row 2 plus row 3. I'll do row 1 plus row 3. The idea is I'm going to use this entry here. I'm going to use it to kill these two. So what do I get? Not changing the bottom row, so I just copied out. Now I'm adding a nice simple operation. For Okay, so that determinant will be, well, it's going to be that -1 down there. That's the 3, 2 entry, so I'm going to get -1 times the determinant. 6, 4, 10, 4. So that is 24 minus 40. 24 minus 40, which is 16. Minus 16. And then my A1 is the first column is replaced with my B. The other two columns don't change. I'll do the same operations this time. Create zeros here using my -1 down there. And what do I get? 0, 4. So what do I get? 24 minus 12. 24 minus 12. 24 minus 12 is 12. So my x1 is 12 over minus 16, which is minus 3 over 4, as expected.